Exercise 1.1.10 Safe use of tools and equipments used in trade. Objectives: record the safety points while using the fitted trade tool and equipments.
These rules are available in lengths of 150 mm, 300 mm and 600 mm. The reading accuracy of the steel rule is 0.5 mm. For convenience, in addition to the mm markings, inch markings are also made on steel rules. Scriber. The scriber is a tool used for marking purposes. It is made of high carbon steel which is hardened. One end of the scriber is straight and the other is bent. For drawing clear and sharp lines, fine points are ground at both ends. Scribers are available in different shapes and sizes. The one most commonly used is the plain scriber. In welding work, it is necessary to scribe lines to indicate the dimensions of work pieces to be sheared or cut by hacksaw, oxyacetylene gas or filed. While scribing lines, the straight end of the scriber is used like a pencil so that the lines drawn are close to the straight edge. The point of the scriber should be ground and oil stoned frequently for maintaining its sharpness. Scriber points are very sharp and they are to be handled very carefully. Do not put the scriber in your pocket. Place a cork on the point when not in use to prevent piercing through the skin or the body. Punches. Punches are used in order to make certain dimensional features of the layout permanent. There are three types of punches. They are center punch, prick punch and dot punch. Center punch. The angle of the point is 90 degrees in a center punch. The punch mark made by this is wide and not very deep. This punch is used for locating holes. The wide punch mark gives a good seating for starting the drill. Prick punch. The angle of the prick punch is 30 degrees. This punch is used for making light punch marks needed to position dividers and trammels. The divider leg will get a proper seating in the punch mark. Dot punch. The angle of the dot punch is 60 degrees, used for marking small dots on the scribed lines so that the dots will act as a permanent mark even if the scribed lines get erased while handling the job. Also, these punch marks act as a witness against inaccuracies in chipping, hacksawing, filing and machining. Hence, they are called as witness marks. These dots should not be too close to one another. That is, the pitch of dots can be 4 mm. Hammer. An engineer's hammer is a tool used for striking, punching, chipping, bending, peening, straightening, forging, riveting. Major parts of a hammer. The major parts of a hammer are a head and a handle. The head is made of drop-forged carbon steel, while the wooden handle must be capable of absorbing shock. The parts of a hammer head are the face, peen, cheek, eye hole. Face. The face is the striking portion. Slight convexity is given to it to avoid digging of the edge into the job. Peen or peen. The peen is the other end of the head. It is used for shaping and forming work like riveting, peening and bending. The peen is of different shapes like the ball peen, cross peen and straight peen. The face and the peen are hardened. A welder uses the ball peen hammer for punching, chiseling, peening, removing bends and for straightening of sheets. Cheek. The cheek is the middle portion of the hammer head. The weight of the hammer is stamped here. The portion of the hammer head is left soft. Eye hole. An eye hole is meant for fixing the handle. It is shaped to fit the handle rigidly. The wedges fix the handle in the eye hole. Specification. An engineer's hammer is specified by their weight and the shape of the peen. Their weight varies from 125 grams to 1500 grams. The weight of an engineer's hammer used by a welder is 1000 grams and for marking purposes is 500 grams. The ball peen hammers are used for general work in a workshop. Before using a hammer, make sure the handle is properly fitted. Select a hammer with the correct weight suitable for the job. Check the head and handle for any cracks. Ensure the face of the hammer is free from oil or grease. Always, the handle is to be held at its extreme end while hammering. Bench vise, chisel and clamps. Objectives. At the end of this lesson, you shall be able to name the parts and uses of a bench vise, specify the size of a bench vise, state the uses of vise clamps, know the positioning of the vise on the workbench, list the uses of a cold chisel, name the parts of a cold chisel and different types of chisels. Identify the different types of clamps used in welding operation. State the uses of clamps. Bench vise. Vises are used for holding workpieces. They are available in different types. The vise used for bench work is called the bench vise. Engineer's vise. A bench vise is made of cast iron or cast steel. It is used to hold work while preparing the edges of sheet plates and pipes by chiseling, hacksawing, filing, before welding them and other hand operations. It is also used to hold welded joints while conducting free bend test on butt joints, fracture test on butt and lap joints. The size of the vise is stated by the width of the jaws. Parts of a bench vise. The following are the parts of a vise: fixed jaw, movable jaw, hard jaws, spindle, handle, box nut and spring. The box nut and the spring are the internal parts. Soft jaws. To hold a finished work, use soft jaws, vise clamps made of aluminium over the regular hard jaws. This will protect the work surface from damage. Do not over-tighten the vise, otherwise the spindle may be damaged. Positioning of the bench vise. Vises are mounted rigidly on a workbench with the fixed jaw in line with the bench edge. The workpiece or the job is held between the fixed jaw and the movable jaw rigidly by operating the handle. The vise is to be mounted on the workbench at a convenient height to the welder or trainees so that he can use it without much strain to his hand, elbow and shoulder. Chisel. The cold chisel is a hand-cutting tool used for chipping and cutting off operations. Chipping is an operation of removing excess metal with the help of a chisel and hammer. Chipped surfaces being rough, they should be finished by filing. Parts of a chisel. A chisel has the following parts: head, body, point or cutting edge, point angle theta degrees. Chisels are made from high carbon steel or chrome vanadium steel. The cross-section of chisels is usually hexagonal or octagonal. The cutting edge is hardened and tempered. For flat chisels, which are most commonly used, The point angle theta will be 60 degrees. Common types of chisels. There are 4 common types of chisels: flat chisel, cross-cut chisel, half-round nose chisel, and diamond point chisel. Flat chisels. They are used to remove the taper or an uneven surface on the edge of the plate and make it flat and chip excess metal off weld joints and castings. It is also used to bevel the edges of a plate or pipe circumference to an angle of 200 to 450 while preparing the metal for groove welds. Cross-cut or cape chisels. These are used for cutting keyways, grooves and slots. Half-round nose chisels. They are used for cutting curved grooves, oil grooves. Diamond point chisels. These are used for squaring materials at the corners. A welder uses a flat chisel to remove excess weld metal from the weld face. He uses a diamond point chisel to prepare a V-groove at the root of a welded joint to rectify lack of root penetration and to rectify a crack on the weld. Chisels are specified according to their length, width of the cutting edge, type, cross-section of the body. The length of the flat chisels used by a welder is 150 mm. The width of the cutting edge varies according to the type of chisels. Point angles and materials. The correct point or the cutting angle, theta, of the chisel depends on the material to be chipped. Sharp angles are given for soft materials and wide angles for hard materials. The correct point angle of 60 degrees and angle of inclination of 40 to 45 degrees will help to cut mild steel easily.